Hi, Algebra 2. This is a video of lesson 9 in Unit 2, and today we're going to talk about even and odd functions. So before we do that, I just want to review with you even and odd degree. So that's a little bit different than what we're going to learn today. Even and odd degree is talking about the highest exponent. So like say I had an equation with x cubed minus 4x squared plus 5x plus 3. All right, my degree is talking about this. That's an odd degree. Or if I have an equation, I'll put a y equals here. If I had the equation y equals 2x squared plus 5x minus 6, the degree is the highest exponent. So the first question to do now is based just on the degree. And I want you guys to remember, if it's an even degree, then the ends go in the same direction. So even degree, ends go in the same direction. And if it's an odd degree, the ends go in different directions. Okay, so obviously if you have an equation, you can see if it's even or odd degree by looking at the numbers. But if you just have a picture, which is what we're going to do in the do now, the even degree, the ends go in the same direction. The odd degree, the ends go in the different directions. Okay, so if you look at these, we'll do them together. Or if you want to pause the video and try it yourself, you can. So the ends on number 1 go in the same direction. This is even. Number 2, the ends are going in a different direction. This one's going up, this one's going down, so this one's odd. Number 3, the ends are both going up, so this is even. Number 4, the ends are both going up, this is even. Number 5, the ends, one's going down, one's going up, this is odd. Number 6, this is down and down, so this is even. Number 7, this is going up on the left but down on the right, that's odd. And number 8 is going down on the left and up on the right, so this is odd. Okay, so that's stuff that you did back in algebra. What we're going to talk about today is even functions and odd functions. So this is different than the degree. In an even function, all right, that's the one on the right here. So an even function, we'll start with that one. An even function is symmetric about the y-axis. So if I'm looking at this y-axis here, I could sort of fold it and it's exactly symmetric. So if it's symmetric about the y-axis, then it's an even function. An odd function is symmetric about the origin. So basically, if you turn it upside down, that would be the easiest way to think about it. Turn it upside down, and if it's the same, then it's odd. So that's looking at a graph. All right, so now let's look at the ones that we had up above. All right, and let's say which of these are even functions and which of these are odd functions. So not the degree, we already did that. Let's look at all the ones that are even. So they're even if they're symmetric about the y-axis. Let's look here. Number 1, well, that's even. Let me get a different color. So this is not the degree. This is whether the function itself is even or odd. So this is symmetric about the y-axis. Number 1, this is not symmetric about the y-axis. Number 3 is not symmetric about the y-axis. Number 4 is symmetric about the y-axis. Number 5, like imagine drawing a line down the y-axis. Is it the same thing on the left and the right? No. 6, nope, not the same thing. 7, nope, doesn't look like it. And 8, symmetric, but nope. So the only ones that are actually even functions are 1 and 4. So the even ones are 1 and 4. And now let's do the odd ones. I'll do the odd ones in green. So the odd ones I'm not going to be able to do. I want you guys to do them. Take your paper and turn it upside down. If it's the same function upside down, then it's going to be odd. All right, so everybody's paper should be upside down. 1 is not the same. 2 is not the same upside down. 3 is not the same upside down. 4 is not the same upside down. 5 is not the, 5 is. Okay, so 5 is the same upside down. 6 is not the same upside down. 7 is not the same upside down. And 8 is exactly the same upside down. So my odd functions are 5 and 8. And the ones that were not even and not odd, then those we just say that are neither. So the neither ones, because they wanted me to do neither odd or even, they want me to list those also. And my neither ones are all the rest that are left. So 2, 3, 6, and 7. If a polynomial function is of even degree, does that imply it's an even function? Absolutely not. Okay, so this one right here, let me just draw an example for you. If both ends are going up, this is an even degree, but it's not an even function because it is not symmetric about the y-axis. All right, so it's an even degree, but it's not an even function. If a polynomial function is an odd degree, does that imply that it's an odd function? No, that doesn't have to work either. Let me draw a picture of one. Okay, so an odd function just means that it is going down on one side and going up on the other side. Okay, so this is an odd degree, but it is not an odd function. If I turned it upside down, it would not be the same. If that point was at the origin and I turned it upside down, then that might be the same. All right. Number 4, so on the next page, the graphs of the following odd degree polynomials are given. State which ones represent odd functions. All right. So these are all odd degree because you can see that they're faced in different directions, and I want to know which of these are also an odd function. If I turn the first one here on the left, if I turn it upside down, is it the same? Absolutely. So this one is odd. Let me get a different color. And the next one, if I turn that upside down, is it also the same? Yes, it is. If I turn this one upside down, is it the same? No, because you could see that this is like a little bit moved over, so it's not odd. And if I turn this one upside down, is it the same? No, it is not odd. All right. Now, we're not going to always have a graph. We're going to have to look at some of these algebraically. So the next step is helping us to figure this out. They want me to evaluate f of negative x for each of the above polynomials. So f of negative x, I'll start with the one on the left. So f of negative x would be negative x to the third, which would equal negative x to the third power. Okay, because I'm doing it to an odd power, then that negative is going to stay negative. The next one, so I have f of negative x. So I'm going to do negative x to the third power minus negative x. So basically I'm substituting in a negative x wherever there's an x. That's what I'm doing. Well, that's going to equal negative x to the third plus x. Well, let's do that next one. So I'm doing f of negative x. I'm substituting in negative x wherever there's an x. Minus 2 times negative x squared plus negative x. So this equals negative x cubed. But this is negative x squared is going to be positive x, so minus 2x minus x. And then I have my last one. I'm going to run out of room. But I have negative x cubed minus, I'll write it up here, 4 times negative x squared minus negative x plus 4. So that gives me negative x cubed. That will stay, the first one will stay negative, but the next one will become, that negative x squared is going to become positive. And then I have minus negative x, which is plus x, and then plus 4. So what I want you to notice on these, algebraically, what's happening, this one, all the signs changed. This one, all the signs changed. This one, positive x cubed, negative x cubed, positive x. This one, let me do it in a different color. Okay, this was the original. Some of the signs changed, but not all of them. Like this changed, but the next one did not. And this changed. So not all of the signs changed. And this one, again, this changed, but the next one didn't change. The next one did change. So that's the key. If you substitute in negative x, if you evaluate f of negative x, What's true for all the ones that are odd is that all the signs change. Okay, so f of negative x, when you evaluate f of negative x, the answer is negative f of x. That is an odd function. So we have that written down. Odd function. A function is odd if it's symmetric with respect to the origin. So that's if you have a nice graph that you can look at. Easy. But if I don't have a graph, a function is odd if and only if f of negative x equals negative f of x. So if I substitute in negative x wherever there's an x, and the result is that all the signs change to a negative or opposite, then that is an odd function. All right. Let's draw in some even ones because I see that they're not drawn in here. If I was to do this one, it's going to look something like that. Okay. And this one looks something like this. Okay. So draw those in. And I'm looking at the graph. Okay, the one on the left is not even. It is not symmetric with respect to the y-axis. The one on the right is even because it is respect to the y-axis. Now let's do that same trick that we were doing up above. Evaluate f of negative x for each of the above polynomials. So if I'm going to do the one on the right, f of negative x, I'm putting in a negative x wherever there was an x. And that results in x squared minus 3x minus 10. And then I'm going to do it for this one on the right, f of negative x to the fourth minus 29 times negative x squared plus 100. So this negative x to an even exponent stays positive. This is negative x to an even exponent is going to stay positive, but then of course the 29 was negative. So I just want you guys to see that in the one that was even, the signs stay exactly the same when I substitute negative x. The one that was not even, the signs did not stay exactly the same. All right, if you're looking at those, let me change that to a different color. Okay, positive, positive, negative, positive, negative, negative. So the signs did not stay the same. So that's the key for an even function. When I substitute in negative x, and I have that written on the next page, so we can just look over to the next page. What is the relationship between f of negative x and f of x for the even function? If I have f of negative x, the result is it stays exactly the same if it's even. Okay. So to test algebraically, so if I don't have a graph, to test algebraically whether a function is odd or even, you substitute in negative x for x and simplify. If I substitute in negative x and it results in negative f of x, then it's going to be an odd function. This is like a little summary right here. Basically, all the signs change. If I substitute in negative x and it results in the same function, that's going to be an even function. So all the signs stay the same. If it's a little bit of both, then it's neither even or neither odd. All signs stay the same. So we're going to do a little practice. We're going to see if these functions are odd, even, or neither by testing, by substituting in negative x. So f of negative x. So I got 2 times negative x to the fifth plus 4 times negative x to the third. Well, a negative to an odd exponent is going to be negative. A negative to an odd exponent is going to be negative. So let's compare this to the original. So I'm looking at the signs of the original and the signs of f of negative x. I lost my equal sign here. Sign change, all the signs change, therefore it is odd. All signs changed. All right, let's try number 2, g of x. So I'm going to substitute in negative x. 2 times negative x to the 4th minus negative x to the 3rd plus negative x squared minus 2. All right, so negative x to an even exponent stays positive. Negative x to an odd exponent stays negative, but then I have that negative that's hanging out in front, so it'll make it positive. A negative x to an even stays positive, and the 2 is just going to stay, obviously. So now let's compare it to the signs from the one above. So the 2 stayed 2. The negative x to the 3rd became positive. So this is a neither. I can see this stayed, this didn't stay. So therefore, it is neither. Some of the signs changed, some didn't change. All right. H of negative x. 3 times negative x, but that's in an absolute value. So the absolute value of negative x is positive x. So I can see that if I'm comparing this and this, all the signs stayed the same, therefore this is even. All signs stayed the same. And this last one, so I got j of negative x, negative 4 over negative x. Well, negative 4 over negative x is 4 over x. So all the signs stayed, therefore this is odd. All signs changed. Okay, because the original is even, was negative, and the new one is positive. This is considered one term, so the term itself in the original was negative, and the term in the new one is positive. So that's why it's not that the top is negative and the bottom is positive, it's just one term. All right, so a little summary of even and odd functions. So an even function has symmetry in the y-axis. F of negative x just results in the function staying exactly the same as it originally was. An odd function has rotational symmetry around the origin. Remember, you're just going to turn it upside down to check. That's the easiest way. And also for an odd function, f of negative x results in negative f of x, and that all the signs change. And if it's neither even nor odd, it doesn't have symmetry. And also, when I substitute in negative x, nothing happens. Some change, some don't.